Let's solve 240 divided by 3. To solve this, we could take this large 3-digit number and divide it by a 1-digit number, or we could take what we know about tens, about zeros and tens, and try to break this up into numbers that might be easier for us to work with. So 240, because of the 0 on the end, I know is the same as 24 tens, or 24 times 10. 24 times 10, anytime we multiply by 10, we'll have the original number, 24 in this case, with a 0 on the end. 240. So 240 is the same as 24 tens, or 10 times 24. So we can come back over here and write this number, 240, as 24 times 10. And then still have the divided by 3 at the end. So what we changed was to change 240, or 24 tens, to be 24 times 10. What we did not change is the solution. These expressions are still equal. They equal the same number. So we can solve either one to get the same solution. And down here we have a little bit simpler of numbers to work with, so I'll work with this one down here. The next thing I'm going to do is look at this multiplication problem, 24 times 10. And I know that in multiplication I can multiply in any order. For example, if I have something like 2 times 3, which is 6, that's the same as 3 times 2, which is also 6. 2 3s or 3 2s is 6. We can change the order without changing the answer. So over here, let's do that. 10 times 24 divided by 3. So we've changed the expression, we've changed what's written here, but we have not changed what it equals. We have not changed the solution. And now I can see a division problem that for me is far simpler than this big 3-digit division problem up here. 24 divided into groups of 3 is 8. It's 8, and then we'll bring down our times 10, bringing down this 10 and the time sign. And then we can use the pattern we already know that we talked about up here. When we multiply by 10, we take our whole number, in this case 8, and we add a 0 to the end, or 80. So our solution, we came up with 80, which means our solution to the original expression is also 80. 240 divided by 3 is 8 tens, or 80. One other way we could have thought about this is 240, as we've already said, is 24 tens. If we divide 24 tens by 3, we end up with 8 tens, and 8 tens is equal to 80. If we have 8 tens, that equals 80. So this is one other way that we could have thought about it, both ways using the 0 or our knowledge of tens to break this division problem down so we didn't have to deal with a large 3-digit number, but could deal with simpler, smaller numbers. Let's try another one. This time let's do thousands. Let's make this one trickier. What about something like 4,200 or 4,200 divided by, and let's see, how about 7? Divided by 7. So here, again, we can break this number down. 4,200, this number 4,200, or 4,200, can be written as 42 times 100. Because our pattern tells us when we have a number, like a whole number like 42, and we multiply by 100, we keep our whole number of 42 and we add 2 zeros now. So 42 times 100, and then we still need to have our divided by 7 at the end. Reverse these numbers so that 42 and 7 can be next to each other. 42 divided by 7, because that's a division problem, a division fact we might already know. 42 divided in groups of 7 is 6. And bring down the 100 and the times sign. 100 times 6 is 600. So our solution going back up here to 4,200 divided by 7 is 600. Or we could have thought about it again, still thinking about place value, but using words here instead of digits. 4,200 is 42 hundreds. 42, I can write that out. 42 hundreds. And if you divide 42 hundreds into groups of 7 or into 7 groups, each group will have 6 hundreds or 600 in it. So either way, 4,200, 4,200 divided by 7 is 600. So here again, we were able to solve a tricky problem, one that had a 4-digit number, without using any long division, but instead using what we know about place value or hundreds and zeros.